Hi, my name is Ella Moore, and today we'll be talking to you a little bit about the designing and testing of the truss that is on the screen right there. And this is for my statics class at HSU. My team that I worked with in the design process and the drafting process was Aiden Wilson and Jillian Snowhook, and I'm very thankful for them. Yeah, let's get into it. So first, I'm going to give you a little bit of background information on this project. Throughout the whole semester, we have been doing truss analyses, and so the main point of this project was to give us some real-life experience with designing a truss and then analyzing it. Our task was to design and test the lightest possible balsa wood truss that can also hold 12 pounds of weight. Some of the requirements were it must hold at least 12 pounds, which I mentioned before. It has to be 36 inches in length, 4 inches in height and width. And it can also only be made of balsa wood and super glue. Here is all of our alternative designs that we considered. The method that we used to pretty much come up with these designs is we looked at all of the basic truss designs and then we made slight modifications to them. We each did 2 different designs and then we came together to discuss them. How we decided on the design that we wanted to do was we created a Delphi matrix and we kind of ranked each of them compared to all of our criteria, and our criteria was time of construction, ratio of weight to load capacity, constructability, aesthetics, members of compression and tension. And as you can see, the Pratt 30-60-90 won. After we decided on our final design, we all did a SketchUp in AutoCAD. This one is my final SketchUp. The scale is 1:1. The units are in inches. The blue members represent 1/4 inch balsa wood, and the red members represent 1/8 inch balsa wood. We would have had more 1/4 inch balsa wood members in the middle, but we ran out of balsa wood, so we had to take that into account. Its height is 3.46 inches and its width is 36 inches. The reason we decided on the Pratt 30-60-90 truss was because it had a good ratio of members in compression to members in tension, and we thought that that would be beneficial. We also thought that the constructability would be fairly simple, considering that it's primarily constructed of 30-60-90 triangles. We then used the method of joints to do a truss analysis in order to figure out the load that each member would be bearing and whether it was in tension or compression. And we discovered using the chart about balsa wood that Dr. Tesfa gave us that the first failure should be expected at joints C, D, and DE at around 20.4 pounds, which exceeded the necessary 12 pounds. Next, I started the construction phase. This phase had a lot less teamwork in it because we had to do the construction of our trusses separately. I got some help from my father, who I'm currently quarantining with. So the first thing I did in order to start the construction was I wrote down all the sizes of wood that I needed and their quantities and the type of wood. So either 8-inch or 1/4 inch. After that, I started to cut my balsa wood to the necessary size using an X-Acto knife. I also measured out and I marked on my ruler each length that I would need so that I could really quickly and easily refer to it. I ended up color coding my balsa wood to make it easy to identify which was which, as you can see right in this photo. I ended up cutting the incorrect size for my, I ended up cutting 6-inch pieces instead of using one long piece for the base of my truss, so I had to go purchase more balsa wood in order to correct that, but I just purchased the amount that I had wasted. Then I eventually sketched out a proportional drawing of the truss, and I placed each of my pieces on the proportional drawing, and then I was ready to start gluing. So as I mentioned just now, I placed the balsa wood pieces on top of my sketch, so I kind of had a roadmap of where to start gluing. I started on one of the corners, and I marked off with a pencil. I placed down my gauze plate, and then I marked it off with a pencil where the glue would need to be. I applied the glue, and then I pressed down my gauze plate for a few seconds until it stuck there. Uh, Pretty quickly we realized that we were going to have to start cutting the members to angles to fit better because they were kind of becoming off. So we started doing that, and it worked out pretty well. And so after construction, we were ready to test. This is kind of what my testing setup looked like. We used two identical chairs. We initially took all of the measurements of all of the working components. So we took a measurement of the piece of wood that we put on top and tied the rope to. We took a measurement of the rope. We took a measurement of the bucket. In order to be able to calculate how much weight was actually used by the truss or was taken by the truss. We also weighed the truss. We started adding weight by adding 4 cups of water at a time because we knew that 2 cups of water is a pound, so we went by 2 pounds. The bucket height was kind of a safety tool. As you can see, it's very, very low to the ground. I think in this photo, it's slightly above the ground. It's very, very close. And that's because we were about 12 pounds in at that point. And we really quickly realized that this was an issue because as you can see, it's almost touching. And with a few more pounds, it was pretty much touching the ground. So we had to do a lot of mid-test modifications. One of those was raising the chair a few times, or raising the chairs a few times. So the first time we raised the chairs was, I think, about at this point, and we did this by putting just some plates underneath the chairs that raised them up a few inches. After we raised the chair the first time, we ended up running out of space in the bucket for more water. So we added 5-pound dumbbells that we already owned, and we added 2 of them. But at that point, the bucket had become, again, too close to the ground, so we had to raise the chairs again. And in the middle of raising the chairs, the truss failed, and some of the members broke. So really quickly, before I talk to you about the results, I just thought I would show you guys the clip of me making it to 11 and 12 pounds on the truss. I'll play it. Oh, shit. 11, 12. Oh, we did it! I was very excited. And now for the results. After the final lift of the chairs, the truss failed at 31.130 pounds, which we calculated by weighing the entire thing and then subtracting the weight of the truss that we got beforehand. The body weight to load ratio was 0.0085 pounds, which I'm happy with. And the type of failure that occurred happened at the joint that is circled in red, and also at this other joint circled in red, and it happened at the same time, which was kind of surprising. It was a torsion type failure in the outer middle connectors, likely due to the bending moment caused by the uneven surface. Unfortunately, I used kind of a wicker chair as my testing setup, and that was a mistake because it was uneven, so it created issues, which is why it failed in such a unique way. We were expecting it to fail at member D, E, and CD at 20.4 pounds, so we got much past that, which I'm very proud of, and yeah. Thank you so much for taking the time to listen to my presentation, and I hope you have a great day.